Hi, Stuart here. This time, non-functional requirements, aka NFRs, aka abilities. We just need 10. Prove me wrong. So here's the story, right? I've been doing this a long time, along with my friends, and if you're a really serious architect that works in the enterprise space, you have to trust that the functional requirements, the user stories that you're going to be asked to build are reasonable. And you should trust but verify. I mean, you should get to know your BAs, get to know their capabilities, get them to be focused on what you care about, right? Which is stories should describe what the desired outcome is, and they should have acceptance criteria that are testable. Because if they don't, you need to find some new BAs. But as architects, we're responsible for the non-functionals. And it's our job to drill into those. And our best ally for that is our QA lead or team member. So when you're doing a project, in addition to having an architect and a BA on the project, and, maybe a project manager, scrum master, sprint master, whatever you want to call them, don't forget to have a QA architect or QA lead, because they are concerned with, can I test this system? How do I know it works? What are the criteria I'm supposed to be testing it to, right? So don't leave them out of the beginning of the project. You will regret it if you do. And so every single time we went to a different customer, we got a different list of non-functional requirements. And many customers either had no list or had a million lists. And that made it hard for us to develop a, playbook for NFRs that said, here are the NFRs, here are we respond to different NFR, criteria or use cases or scenarios. And so we could build a playbook and not only have a checklist for teams that were incepting new systems or extending existing systems, but more importantly, everybody had the same understanding of what a non-functional requirement meant, and a particular user story could cover more than one non-functional requirement category. And frankly, we got tired of a lot of dumb meetings over and over and over again where people are haggling about the meaning of a non-functional requirement, and it just had to stop. And sometimes they were in violent agreement, and that's just silly. And meetings are expensive, and architects and QA leads and BAs are expensive, and the customer's time is expensive, so let's just not. So my other pet peeve about requirements, and this is especially true of non-functional requirements, is that they should be smart. And when I say requirement, user story, whatever, don't care. But they should be smart. And there's this guy, George T. Doran, and he is super smart because he came up with this really easy to understand criteria. So every time you're reading a design document, or every time you're reading a user story or a feature or whatever, you can ask yourself, are these things smart? And if the answer is no, that artifact is no good in a big bad way, because effectively you're setting yourself for failure if things aren't smart. And everybody can get this, right? This is something that should be universal. And I often start projects off with an all-team meeting where we go through all of the different things I want people to, how I want them to think and how I want them to care about things. And this is one of my favorite slides because, it speaks to being able to judge things, artifacts that are produced. And if they fail any of the SMART tests, then what they are paperweights. So, this is the deal. We sat down and took all the requirements. We went through a bunch of different standards documents, right? There are lots of good standards organizations. Some of them are business focused. Some of them are developer focused. Some of them are DevOps focused. Some of them are system focused. Some of them are focused on lots of other good things that you should care about. And we said, what is the minimum number of these that we could come up with that a requirement, would fit into? And it could, again, a requirement could fit into more than one of these. So that's okay, right? And the reason is that non-functional requirements occur naturally as part of telling, for example, a story or a bug. But that story or bug could impact more than one non-functional requirement along with functional areas, business areas, things like that, all of which should be in a tag cloud, right? So that's how we look at them, right? We write a bug that says this API takes on average 3 minutes to, make this call. Our SLAs are, mean time of 30 seconds under the load of blah, blah, blah. And we'll talk about all that stuff more later. It isn't true. Therefore, here's a bug. And that impacts these business subsystems and these concerns and these non-functionals. And they're all part of the tag cloud. And so if you're dicing, slicing, and julienning because you have some sort of management or compliance function, it's much easier to find. NFRs do not make natural stories on their own because they're so unrelated to something else, although there are base things like you can have a user story that enumerates all of the supported browsers for the web UI, and then all the other web UI stories can have it as a prerequisite, right? You can do that. But they aren't generally comfortable fits for stories. And we don't want them out of the tree. So, tag cloud. Talked about this last time. So let's start with capability. So capability, 80% of it is the functional requirements, right? But the other 20 is going to take potentially another 80. And so here are a whole bunch of questions that we came up with to try to find the Here are a bunch of questions we came up with to delve into capabilities the business might not otherwise mention, but they actually need. And so, you should be asking questions about the business capability, and that's the BA's job. But as the architect, your job is the other 20%. So, there's that. Compatibility is my least favorite one. I have gotten some blindingly bad ideas from different segments of usually the business users or their IT organizations. Early on in my career, I heard a lot of it has to work on both SQL Server and Oracle. That's not a good idea. These days, it must run on all these OSs or all these browsers or whatever. And the way you get around that is you say, well, in order to get the business capabilities that you want, we have to start pruning this list down. And, but just be wary. Compatibility things are almost always a big red flag, and they will cause pain, so much pain. Operability is the ability to have sustained engineering. I talk about sustained engineering in a lot of my YouTube videos. These are the 5 elements of sustained engineering. If you're unable to do any of these in an automated, repeatable way, you fail the operability test. So it's incredibly important you build systems that are operable, and the bigger the system and further away it's going to be from you. E.g., you can't just walk down and elbow the server in the rack. It's up in the cloud or whatever. The more important operability is. And there are lots of great videos on operability from DevOps people, and you should go watch lots of them. But if you do not have operability as a theme as you are gathering non-functional requirements, something has gone badly wrong. Maintainability. is more complicated than just indent everything with 4 spaces or spaces versus tabs or formatting. It turns out that most modern programming systems have A, auto formatting, B, diff tools that are insensitive to formatting full stop, right? So what you really want to do is make sure that you have organized things to make it obvious how to find all these things, and that they're generally done in the same way. And that may mean, every file of this type has to have this header or whatever. And it's really important that you quickly close in on a standardized set of best practices. And one of the best ways to do that would be to set up a center of excellence. In other words, build a community around whatever that thing is, DevOps, infrastructure, tooling, whatever, and upgrade and enforce your standards using automation. And again, you'll hear automation as a theme. If you don't automate it, you can't have sustained engineering. If you don't have sustained engineering, it's really hard to get success. And again, from a maintainability point of view, there's nothing more poisonous than the 2 watches problem alluded to previously. Here's the other thing, and man, I see this a lot, and it's a terrible idea. You've got this human org tree, because those never change. Yeah, they do. So, do your organization based on the system model. I use DDD. So when I break things into pieces, and I need to break things into different repositories to make each code base a manageable size, I break it down following the system model into smaller and smaller pieces until I get something that's a good balance between having too many repos and having these repos that are kitchen sinks that have everything into them. One advantage to lots of relatively smaller repos is it's much easier to control your release process and to keep those repos in good hygiene than if you have one big monolith repo. Performance. So many definitions, so many of them are correct. And you'll notice the thing about all of these use cases is they're smart and incredibly specific. And so specificity, right, is the first thing in the SMART paradigm. And if your developers or QAs read the user story, especially user stories about non-functional requirements or a bug with a non-functional requirement problem, and don't see that they're smart, they may not know how to fix it or even retest it. So in the performance area, especially when people start talking about, it has to perform well, you go, what does that mean? Right? And here are some areas in which you might mean things. There's 5 areas. This doesn't cover all the possible performance areas. I could do an endless set of videos just on performance. But here's some areas that if you're not thinking about, you should be. And you should define some non-functional requirements around the system parameters that are talked about in this slide. So, be thoughtful about performance things because they can be really arbitrary. And if you're building code for someone else and your definition of performance and their definition of performance does not agree, you're never going to come to enlightenment about whether or not you've delivered the thing they actually need. Portability. The number 1 and number 2 areas of portability are typically the need to white label tenanted systems or have every where you have every user have sort of a custom user experience, whether that's, preferences or what shows up on the widgets that show up on their home screen or whatever. And I'll point out that ability to do white labeling is what drives, in part, your ability, at least in UIs, to be world ready. And one of the areas of significant drift is when the business comes to you and says, you know, we're going to ship the first one in English or French or whatever, but eventually we want it to support potentially any language on the face of the planet Earth, without understanding that without significant initial investment, not only in the framework to support that at all different layers of the software, but in order for QA to be able to do testing and for developers to be habituated to writing things in world-ready ways and being sensitive to culture, and if you're a .NET developer, you know exactly what I'm talking about, it's very challenging. And on UIs, if you have something like German, Thai, or traditional Chinese, Arabic, or Hebrew, those can be some very challenging UIs. And there's a couple of ways to deal with that. One is to provide different UIs for different cultures. And as long as all your business logic is in a service tier or in some sort of set of shared libraries, that's not horrible. The alternative is, if you're on the web or whatever, that you can have different kinds of widgets. But this is a non-trivial problem, and this can blow up the budget of your project like nobody's business. It is astounding how mistakes made in documenting portability and then setting realistic expectations can totally throw off a project. And again, if you don't invest in the required testing for portability, you're just bitterly going to regret it later, because you'll have a million bugs where something doesn't work right on this screen in this language with this particular set of data, and it works fine for everybody else. And that's just misery. So when we talk about performance and availability, particularly, we have to go and think about some industry standard metrics. And probably one of the oldest and most famous industry standard metrics are the nines. Here's a nice nines chart, courtesy of our good friends on Wikipedia. And when you're having discussions about how much downtime you're willing to tolerate, one of the worst answers you can hear is never good for you. And the answer is, do you have a budget of infinity? Because realistically speaking, business systems are affordable at 3 nines. And you'll notice at 3 nines, the downtime per year, unplanned downtime per year, I'll point out. This doesn't include maintenance windows, hotfix windows, things like that. We'll talk about those in a bit. Is only about 9 hours a year. So getting to the next 9 is probably another 80% more money in infrastructure, and it makes the job of being an architect and an implementer an order of magnitude harder, right? So you can go read up on nines. There's lots of ways to get to reliability. Parallelism, right? No single points of failure. Lots and lots of tricks to get to reliability. But this is one of those metrics where not only is specificity required and measurability, but you have to be really, really, really specific about time durations and about things like maintenance windows and things like that. But if you're an architect or a senior developer, you should just have this in your head, at least, 3 nines equals 9 hours of downtime a year, unplanned. And that, in the big scheme of things, unless it's an incredibly rare system, like, bigcommercesite.com or, indispensablestreamingservice.com, where paying for more nines is actually in their best interest. Most business systems, 3 nines is the appropriate balance of spend and aggravation to the people who you built the system for. So, reliability gets kind of a bad rap. By the way, my primary focus these days is reliability engineering. And the number one reliability problem is other human beings. Getting rid of them would be swell. but not realistic. So, when you talk about reliability non-functional requirements, you really need to spell out all this stuff in gruesome detail, especially on how you measure some of these things. And reliability things should always be accompanied with a testability tag as well, because, you can't assure reliability unless you have a test for reliability, and you can't really have a test for reliability unless you've built the observability, that is to say the operability, into place, right? There's nothing to measure, so you don't know if your system is reliable enough or not. By the way, 100% reliability is a joke. There's no way to get 100% reliability. Now, big, scary internet companies that have way more budget than you ever will can get really close, but even they have outages, right? I mean, I love Azure, but Azure's had some outages that were pretty vexing. I love ADO, but ADO's had some outages that were pretty vexing. Even other things have had outages. So there's no such thing as 100% reliability. And the best way to get to reliability is to focus on the other non-functional requirements and beat technical debt to death and make your system testable. So when you're an architect or senior developer, the risk triad is fundamentally what you should think about. And in your risk register, which is not some spreadsheet out in the universe, it's in your tree, right? The tag cloud for each risk should include at least one of these. And a risk can impact 2 out of these or 3 out of these. But fundamentally, all risks devolve down to integrity, confidentiality, or availability. You are designing subsystems, right? You've done your DDD, we talked about last time, and I have a whole course on it. And you start to talk about and think about designing each subsystem. This is another one of those things that should just be in your brain. And it's got a super easy to remember acronym, CIA, confidentiality, integrity, availability. By the way, confidentiality is on top for no other reason than that's so we can make a pyramid. They're all equally important in theory, and the business will have different weights for these for different parts of the system, e.g., different subsystems may have different non-functional requirements about these, which fall under the bucket of security. So again, this is a topic of non-functional requirements way too big for this overview video. I do have additional YouTube videos that cover this topic, and there'll be more in the future, I'm sure. And there are lots of great YouTubers that talk a lot about security. But I just want to point out some danger Will Robinson moments to you. And that is, if you ask them who their penetration certification security vendor is, and they point to someone and they say, it's Susan? And I go, oh, Susan works here? And they go, yeah. And I go, no. If your stuff is forward-facing to the internet and you have OPD, other people's data, you really need to have outside certifications and testing. And if you're a publicly traded company or you're in certain segments in certain jurisdictions, this may not be optional. This may be a rule. But I'm just saying the best practice is have real experts. Don't fool around. Somebody who's read a Internet Security for Dummies book is not qualified to do security. Real security professionals get security training, get hired on to corporate information security teams as junior members. They learn through experience, and then after a few years, they're a journey person in that area, and they get their certification renewed every single year, and they go to X number of hours of continuing education, and they have budget, and they have tooling, and they have a mission statement, and they have performance non-functional requirements that say, you know, if this stuff happens and you didn't warn us about it, you didn't do your job, enjoy your new career in food service. So if you don't have a corporate information security team or something that smells like that, you know, chief security officer or whatever, that's a bad sign. And again, you should ask the governance organizations in the customer what the rules are and where to find them. You do not want to have to re-engineer some of this stuff after you have built it. It is a secure by design, secure by implementation, secure on purpose and not by accident. Which brings us to why you should, when you're talking about security, have this graphic up on the wall or virtual wall, right? And everybody, when they're talking about specific non-functional security requirements, should indicate which of these eggs the requirement applies to or is implemented by. And if they can't, that's a really bad sign. So an example of network security might be a firewall, right? So they say, well, we don't want to allow these ports on these traffic routes on this set of subnets. And where is that? That's in a network security, document attached to a feature with a cloud of security and probably infrastructure and some other tags, right? So you can find it. VMs will be patched using the following patch schedule, and the patches can only come from this place, etc., right? So when we're talking about security non-functional requirements, you damn skippy better be able to point to which circle in here does that apply to. You will have a pen test every quarter, belongs to policy, procedures, and awareness. That pen test is done by a vendor, right? Again, policy, procedures, and awareness. Data security classification policies are part of data security. And by the way, this is a place where I've seen teams go horribly wrong. Because what happens is during the domain-driven architecture sessions, you identify the major subsystems, the domains, and you break those down. You say, well, we need these kinds of data. And then you start thinking about design, and then you start making implementation choices. But you should stop and make sure that as part of your data dictionary process, which ensures that you have consistent semantics and syntax across all your data and element types, that you also have another piece of metadata that says how confidential is it. And there are a bunch of standard models for classifying data by data security, and they have lovely descriptions and so on, and you should use one. And then you should make sure that the one you're planning to use is approved by your compliance organizations, ultimately legal. Because you can get in a lot of trouble. Data leaks when people are working with data and are not cognizant of the data security policy that is required, and they code in such a way that they could have disclosures that are inappropriate or modifications that are inappropriate, right? Any of the Stride things, really. And again, if Stride's new to you, go watch my video on Stride. Supportability. Boy, do these people get the short end of the stick. I love support. If a good support organization is worth so much more than they cost, because they are the people who are going to be on the front lines taking questions and comments, and sometimes poorly tempered people of high rank. And they are the organization where, those human skills that us architects tend to want to ignore are absolutely key. But they can't succeed as an organization without non-functional requirements. So things like time to resolution, time to engagement, the things we talked about before in terms of reliability. If the reliability rules aren't written down and they can refer to them, they don't know if they've met their service level agreement. And that's a very bad thing. What are all the rules around support? Those things are non-functional requirements that should be captured, right? Just part of a mature system. For testability. Like I said before, if one of the testing organizations comes to you, and it could be many of them, right? But quality assurance, support, and the business are typically, your high bit testing folks. And they say it's really hard to validate whether the system is working the way we think it should. You have done a terrible design/implementation. And potentially, you've made a poisoned architecture. And that's just horrid. And but you don't have an infinite supply of budget for tests, right? So you should test based on risk. Test cases should, be written and executed in association to a risk. And, of course, the functional and non-functional requirements, right? It's a matrix of inputs to your testing program. So that if you start running out of budget or time or people or whatever, the iron triangle, at least you're trying to work down your test scenarios from highest risk to lowest risk to the system or its data. And conversely, if, you have fully automated testing and you can do some synthetic transactions, that's a really good sign of maturity and testability. And one thing that you want to be wary of is that test coverage as a number, as a percentage, particularly for lines of code, isn't comparable unless you standardize the format of the code that you're testing and that everybody's writing code in the same language, which they're not, right? The database guys are going to be writing stuff in SQL, and the front-end people are going to be writing stuff in Angular and whatever. So test coverage as a percentage by line of code is a terrible metric, but test coverage by test scenario, risk, top down with weighted averages based on the risk category, the severity, right, is an excellent and stable metric across all implementation systems. My name is Stuart. Thank you for your kind attention.